So we discussed last week about the combination circuits and how can we apply KCL, KVL to these circuits, and we can calculate the parameters for the given circuits. Now let's move to this is one more question. I think this one we covered already. And what is there? They are explaining here that Kirchhoff law can be applied to check on your answers. Like you can check here Kirchhoff's current law. It means the total current is basically the sum of individual currents. And we know that the total current is coming from this battery, which is equivalent to I1. So IT is equal to I1, which is 29.6 milliampere, which is the sum of I2 plus I3. We know this thing, right? Similarly, we can also apply KVL, Kirchhoff's voltage law. So if you just add V1 and V2 voltage drop, which is basically V1 and V2, if we follow this path, as I mentioned earlier, that we can apply KVL to any path. If we go this way, and then we go this way, down, then from here to here. Okay, so this is a complete path. So we can see that we add V1 plus V2, we are getting 10 volts as a result. Okay, so this is about the KVL and KCL, which is applicable there. Next thing, guys, coming here, which is basically loaded voltage divider. What is a loaded voltage divider? You look here, basically this is the combination circuit. If you look, okay, so in a combination circuit, why it is combination? Because you can see R1 is connected, with this battery this way, and your total current is flowing this one. But this current is splitting here in I2 and I3. It means I2 and I3 is basically they are in parallel connection. So here is a point. And for example, if we take the output at this point, let's say the point A, and we just ignore for a moment this R3, just ignore it. Okay, so we want to check, okay, how much voltage is here across this point, and if we measure from here to here, so what will be that voltage? That voltage will be the voltage across R2. Am I right? If I just check the voltage between this point A and the ground, just ignore this R3. So that voltage will be the voltage across R2. Do you agree? Guys? Can you hear me?
Yes.
Yes.
Okay, what I'm asking, if you measure voltage, if you connect here voltmeter, for example, so what is this voltmeter will give you the reading? We are connecting between point A and point this ground. What will be that voltage? Will it be the voltage across this resistance or not? R2, because R2 is connected between point A to ground. Are you getting point?
Yes.
Yes.
So this means is that if you just calculate at that time, so we can apply voltage divider rule or not? Because if we remove this R3 here, it means it is a simple series circuit. And in series circuit, we can apply voltage divider rule. So what will be the output at that time? V2 will be the resistance, which is R2, okay, over the total resistance, which is R1 plus R2, then multiply by the Vs. So this way we can calculate the voltage across R2. But when this R3 is connected parallel with R2 now, so if we just ask you to calculate the voltage from this point to this point, you cannot just now calculate voltage by considering R2, because the total resistance we need to consider, and now both are in parallel. when they are in parallel, so we need to find first the equivalent resistance. First, we need to calculate the equivalent resistance. Then only we can calculate how much the voltage across point A and ground. So what is a loaded voltage divider? So first they are saying the voltage divider equations was developed for the series circuit. Recall that output. Yes, we know this one, this series one. But a voltage divider, please check, with a resistive load is a combinational circuit, because once we connect this load or this extra resistance R3, so this circuit become now a combinational circuit. Okay, and the voltage divider is said to be loaded. So this time that was a voltage divider. Now because R3 is connected, and let's say R3 is a load. Okay, so this is a combination circuit. So what they said, a voltage divider with a resistive load is a combinational circuit, and the voltage divider is said to be loaded. So we call that one a loaded voltage divider. The loading reduces the total resistance from node A to ground. Are you agree with this point? Because of this connections R3, what will happen if we measure the resistance between these 2 points? So the total resistance will reduce or not? We discuss this general concept when you connect the resistances in parallel. So the total resistance will reduce or not?
Yes.
In parallel, yes, reduced.
Yeah, in parallel it reduced, right? So now because R2 and R3, they are in parallel, so definitely the resistance, total resistance will reduce. So if total resistance will reduce, the voltage drop will also change. So this is the point. So what they said, the loading reduces the total resistance from node A to ground. So if the resistance will change, definitely voltage will also change. So how can we calculate the voltage in this situation of a loaded voltage divider? This is next what we are going to learn now. So you look here first, what is the difference between loaded and unloaded? See, this is unloaded. Unloaded yani, you look, we are not connecting the load here. We are just taking the output here, but we are not connecting any consumer here. So for example, we have a 10 volt battery, but we don't want to give this 10 volt to any source, any supply actually. We want, for example, 5 volt. So what we can do, we can have a divider circuit. So this is a divider circuit. We know that voltage divider circuit. So in this voltage divider circuit, what will happen? The total voltage, which is 10, will divide into 2 parts. Some will go there in R1, someone will go there in R2. Are you agree or not? It will divide into 2 parts or not?
Yes.
Okay. So now you can see both the resistance are equal value. Okay. Both resistance are of equal value. So how much will be the V out in this situation? V out, if we measure across R2, we know that V out yani V out means, what is V out means? V out is same as V2. How much it will be? Can we calculate it? You can quickly calculate. It is not time consuming. It's very simple. Yeah, it will be 5. Why, Majid? May I know the reason?
Using the formula.
Using that formula. Also, you can see both resistance are of same value.
Yes, so it will equally divided.
Exactly. So the voltage will equally divided. Exactly. Or you can apply the formula. What is the voltage divider formula? R2
over R1 times
plus R2 multiply by Vs. Exactly. So yes, you got the point. So V out will be, you can simply say 5 volt. Clear? So this is what we call unloaded output. Unloaded output. Okay. Now guys, look the second one. So here we connected the load. Here we connected the load RL. Okay. So now this circuit is called loaded. So now if we want to calculate the V out, yani from here to here voltage, so definitely we cannot directly calculate. So for example, if I give you some value of this resistance, okay, let's suppose it is 1K again, 1 kilo ohm, and I am asking you guys how much is the V out. So how you will be calculating? So any idea, guys? Can you tell me how can we calculate V out in this situation? Try. What do you think? How can we calculate V out now? Yeah, now. Do you remember equivalent circuit? We can find equivalent circuit. We can find equivalent circuit. So here R2 and RL, they are in parallel. Are you agree with this point or not even? Because no one is talking.
Yes, agree.
Yes.
So if this is a parallel, so can we simplify this design or draw the equivalent circuit like that?
Yes.
This is the point A, same point. This is R1. And let's give the name to this one, RA. And how do we calculate the RA? RA is the parallel combination of R2 and RL. R2 plus RL. Are you getting?
Yes.
So how much will be the RA now? 1 multiplied by 1 over 2, which is 1 over 2. So 0.5 kilo ohm. So now we know RA. So we what is that one? This is V out basically. So now you can apply the voltage divider here. So basically we need to find first this equivalent circuit, then we can apply the voltage divider. So what will be the V out? V out will be the voltage across RA. Getting the point? Voltage across RA. So what will be the voltage divider formula now? It is simple series circuit or not this time?
Yes.
So what we need? We need the voltage drop across RA resistance. So we are applying now voltage divider because this is given 1 kilo ohm. This RA is 0.5 kilo ohm. Okay. So apply here voltage divider. So what will be the formula? V out is equal to V out equal to don't you remember the voltage divider formula? I just wrote here. Guys, please focus. Otherwise, I will not take care of whether you are listening or not listening. I will continue and I will not provide the recording. Keep in mind, if you are thinking recording is going to be there, I will not give you recording. Keep in mind, this is a live lecture and it will be live. You want to record, you can record, but I will not provide recording. Be serious. Otherwise, I will be not serious. Then I will say, okay, this is like that. Then I will solve and we continue. If you want to be silent, be silent. I will not take care. I'm telling you, I will finish my lecture. I will continue. Then you will survive. Yes.
Equal R2, RA.
RA.
Divided RT or R1 plus RA.
Okay.
Multiply by VS.
Okay. Yes. Multiply by VS. All right. Put the value. RA is 0.5 and the total is 1.5 multiplied by 10. So 50 over 1.5. Calculate how much you are getting now. V out.
3.33.
Yes.
3.33 volts. So you can see the difference. Now this is V out, this is the another V out. This is the unloaded and this is the loaded. So we know that when we connect the load, total resistance is reduced basically. So voltage will also drop there. That's why here the voltage drop. Okay, here is that one. So this way you can ask, we can ask you calculate the loaded voltage, we can ask you unloaded voltage. So this way you can calculate it. All right. Let's see this question. So question is that here, determine the unloaded output voltage divider. Unloaded output voltage divider. So when say unloaded, it means we don't need to consider the load RL here shown. So we can ignore it and then we can calculate it. So how you will be calculating this? We unloaded yes. What will be the formula for the unloaded?
R2
Yes.
divided by R1 plus R2 multiplied by VS.
Vs. That's it. So this way you can calculate. Clear? Next, determine the loaded output voltage. Loaded. And now the load value is given. So how we will be calculating this one? What I should do first?
R equivalent.
R equivalent means I can give the name R L2. RL2. R2 and L2. Any name we can give, right? Or
Yes.
R2L, whatever you can give like that. So now they are in parallel. And what is the value of this one? 10 kilo ohm. And this is also 10 kilo ohm. So what will be the RL2?
5.
Yes, it will be 5 because they are in parallel. So you don't need to apply the formula because you know the basics. So sometimes you can save your time this way. So now I have RL2. So after knowing RL2, now I can get V loaded. Okay, V loaded. So now tell me the formula. V loaded equal to
RL2
RL2 over
over R1 plus RL2
RL2. Okay.
VS.
Vs, exactly. Yes, this is the way. So RL2 we already calculated 5 over 4.7 plus 5 multiplied by 5. This way we can calculate it. Clear?
Yes, clear.
Yes, clear.
Okay. So this is the answers which you can see here. Concept I explained to you, answers are there. Okay, so both are there. And you can see the difference also. The V which is unloaded, which that is 4.3, 3.40. Okay, but here it's dropped 2.58. The reason the total resistance here also dropping because of they connected in parallel. That's why this is the reason. So this way you can calculate loaded and unloaded voltages. One more question. What is the voltage across R3? So which case is this? What they are asking basically to you? What is the voltage across R3? So is this loaded?
Yes, loaded.
Exactly. It is a loaded because the load is connected there. So R3. So they are asking, okay, how much is the voltage across R3? So what you will do first?
It's parallel with the R2.
Okay. So what we will do now? First step.
R2 multiplied by R3 over
Okay. So yeah. Okay. We need to find a parallel combination. So we can give the name R23. Is it okay? Or R2,3.
comma 3.
And then, yeah, then write the formula. R2, R3 over R2 plus R3. Okay, now put. So 470 multiplied by, this is 2.2 kilo ohm. Okay, guys. So we can convert this one into ohm or kilo ohm. This is the point here. So check it, this one quickly. If I convert, it will be the in ohm. Okay, then we can add this one, 470 plus 200 20. Okay, get it? How much you are getting this way? R23.
$387.
387.
Point
Is it like that?
0.26.
Point 26. Okay, you know your answer is correct. How can we check it? Which is the minimum resistance here? 470.
Yeah.
And your answer is less than this one. Do you remember that concept I told you?
Yes.
Okay, yani it should be less than the least resistance in the combination. Khalas, once you get it, now you can calculate V3. And you guys, you know V3 is equal to V2. They will be same because now they are in parallel. So V3 or V2 is the same way we can calculate R2, 3 over R2, 3 plus R1 multiplied by Vs. Now put the value 387.26 over 387.26 plus 330 multiplied by 15. Get it? How much you are getting?
Eight 0.09.
8.09 volts.
Volt.
Correct? It means is that in V2 and V3 will be something like that. Okay, guys, if I ask you now, how much is V1? How much is V1?
15 minus 8.09.
Exactly. It's because we can apply KVL this way, this way, this way. Any closed loop, we know that. And here we know the drop. We already know the V2. This is V1. So we can say V1 is equal to Vs minus V2. Sorry. So it is like 15 minus 8, which is 7 volts. It is almost, we can, if I ignore this one, it is like that. So this way we can simplify this type of circuit. You can check now. Okay, so solution is here already given. You can check the answers. Okay, so 8.10 because 8.1 yani you calculate the same. 8.09, your answer is more accurate. Okay, so this is the way to simplify this type of circuits. Next thing, load current and bleeder current. Now guys, what is this load current and bleeder current? So in the previous example, we have seen that there is a load is when the load is connected, the circuits is becoming basically a combinational circuit. Okay, this one. But here in this example, we have two loads. If you look closely, we have two loads. One load is here, two tapping, and one more load is here with this one. Or what you can say, another load is here, right? Two loads are connected. And how they are connected? They are not connected to the same point. Actually, they are connected to the different point. So one is connected to the point A, and then we are measuring with respect to ground. Another one is connected to point B, then we are basically measuring with respect to the ground. So the thing is that if the total current, again the directions, you know that all what I said, I always consider that the current is coming this way. So total current is flowing here, guys. And when the current reach to point A, what will happen? Current will split or not?
Yes, well spent.
Yes, yes.
split. So some current will go here in the load 1, remaining current will go here in R2. Agree?
Yes.
And then after reaching to the point B, current will again split.
Yes.
So one current will go to RL2, another remaining current will go to R3. Agree?
Yes.
Yes.
Okay, so the now thing is, the current which is flowing in the load, it is called the load current, which is, they are writing here IRL1, leave the directions. Another current, which is another load, which is IRL2, which is flowing in this one. So these are called the load currents, okay? Because there are load currents, another is bleeder current. Okay, so now what they said, that after subtracting the load current from the total current, which current is remaining? I3. And this current is called the bleeder current, or the remaining current, what basically we call. Okay, so you can just read it, what they are writing here. You can easily understand. So the current I2 is composed of two additional branch current, IRL2 and I3, which is IRL2 and I3. Current I3 is called the bleeder current, which is the current left after total load current is subtracted from the total current in the circuit. So how can we find the I3, or I can say I bleeder? I bleeder will be the IT, yani the total current which is coming from here after subtracting the first load current, which is that one, and then subtract another load current. So what is remaining? I3. This is called the bleeder current. Did you get the idea now?
Yes.
Idea is clear, right? What is a bleeder current and this one. So now, see how can we calculate that one, guys? If I ask you, guys, calculate all the currents. So how can we calculate? Now, I just wanna hear from you the steps. How can we approach? Because we need to calculate all the currents. We need to finally calculate the bleeder current. So it's a simple circuit. We need to simplify this one first. So how we should approach?
RL2 with R3 parallel.
RL2 with R3 parallel, absolutely, exactly, fine. Then
R2 with R3 will be series.
then R2 with the combination, right?
Yeah.
Okay, it will be in the series, all right. Then
The combination with RL1.
exactly, with the RL1. Okay, then
Calculate the current.
no, then R1, nah? Still R1 is there.
Yeah.
So R1 will be in series with this combination. Getting? Okay. So what you said, first you said this is a combination because they are in parallel. So you will solve this one first. Then after you will calculate with that one. Okay, we'll approach this way. Okay, let's calculate all the currents quickly. So I need your help to calculate it. So I'm writing here. First, we can say, let's give the name RB. What RB? Do you understand what is the meaning of RB? Any resistance at that point. I'm giving the name RB. So what it will be? RB. This is a parallel combination, R3 and RL2. Getting?
Multiply them over some of them.
Yeah, R3 multiply by RL2 over R3 plus RL2. Calculate that one. 6.2 multiply by 100 over 106.2. Calculate how much RLB is coming.
5.83.
5.83 ohm. Sorry, kilo ohm, right? Kilo ohm. Okay, now you reach here, this point, and you know that this is gonna be in series with the R2, right? So what will be the RA? Any resistance at point A? It will be R2 plus RB. Are you getting my point? Will it be R2 and RB or not?
Yes.
Oh, okay, because it's in series, as you said. So R2 is given to you 6.2 plus 5.83. So calculate RA.
12.03.
12.03 kilo. All right, guys.
Yes.
Exactly. So now this way, if we just redraw the circuit, this will help us basically. So I'm going to redraw that circuit, which is going to help you. So when I redraw the circuit, this circuit will look like that one. Okay. And now this is point A, and this is our L1, and this is our A. This is our A, and now this is R1. Okay. This is something. So guys, after getting RA, what is the next step?
RA connected with the L1.
Yes,
parallel.
it is parallel with that one. Absolutely. So yani we can now, we need to calculate its parallel combination RA and R, then this one. Okay. So either we can say RA. Okay, it's fine if we are saying RA. So get the parallel combination first. So when RL1, RAL1, we can say it is a parallel combination, which is RA multiplied by RL1 over RA plus RL1. Okay, write the values. So RA you calculated already 12.03 multiplied by 100 over 112.03. Calculate how much it is coming.
10.73.
10.73 kilo. Okay. So now this is how much you calculate until here, right? What next we have to do now?
R1 with the combination.
With the combination, yeah, in order to calculate the total current, we can do this one. Okay, so yani we can calculate now R total, which is R1 plus RAL1. Are you agree with this point?
Yes.
Okay, so how much it is now?
22.74.
Yeah, this is 12 and this is 10. So 22.73 K exactly. So this is
74.
Okay, 7473. It is like that. So next we can calculate I total, IT. Okay, VS over RT. Calculate how much it is coming. VS, you know, 24 already. How much it is coming?
1.05.
1.05. May I know the unit?
Ampere.
Check, be careful. Don't just focus your attention towards the calculation. You should also check the units, which is very important.
Ampere.
Ampere. All the time it will be ampere, regardless whatever is the value.
ملي دكتور.
Why milliampere? May I know?
Kiloampere.
Kiloampere. Have you heard about the current in kiloampere?
No.
So then, yeah, just you are trying.
Ampere.
If not kilo, any ampere. Again trying. And you will lose the marks. And definitely I will cut maximum marks for wrong unit because it's so simple. If you cannot understand, then it is difficult.
milliampere.
I told you, you should check the value of the resistance, which is in denominator. And now it is in kilo. When it will go in numerator, it will be in milli. So be careful about it. Otherwise, you will lose the marks. This is kilo. How you write kilo? 10 power 3. When it will go up, it will be milli. And I told you these things. This is milliampere. IT. Okay. Now you know the total current. So total current and the I1, will it be same or different? Total current which is flowing here, is it same as the I1 or different?
Same.
Same. So you reach to the point A. When you reach to point A, there are two currents. One current will go here, one current will go here. Agree?
Yes.
Yes.
So if we calculate the right side, this current, this is basically that current. Getting point?
Yeah.
This circuit and this circuit, they are equal. We know that. And basically the current which is reaching to the point A, which is reaching to this point A, here, it is splitting into two parts, here and here. So if we know this current, this is basically that current. So how can we calculate this current? This current, I can give the name IRL1. So we know the total current, which is IT. Okay. And then this current is dividing here. We can also calculate that current. Let's say this is I2, because if you look here, this is I2. It is a combination because it's going in the combination. And two current is leaving from this point A. One is this and another is here. So we need to calculate I2 and we need to calculate this current. So how can we calculate? What is the way to calculate the currents here? What is the way to calculate the current here?
Parallel.
Tell me, how can we calculate these currents? We have discussed everything. Here is nothing new except the concept, how they are connected. Everything is we already discussed. So we know that the current is going here and here. So total current dividing into two parts. So which formula we can use to calculate the current now?
Divider rule.
So why are you not saying current divider rule quickly? Why are you taking this much of time? So we can apply current divider rule because if the current is dividing into two parts. Okay, if you can apply current divider rule, so apply current divider rule and calculate IRL2. So tell me the formula now. I want to calculate the current. Which current? IRL1. So IRL1. What will be the formula? Current divider formula.
RL1.
Yeah, this is first of all, you should know, I told you the basics formulas. Now, if you disturb with the formula, then it is gonna be different. I told you the difference between voltage divider and the current divider formulas. Then no one revise, nothing, you just blank now. At least I can not change my screen, but you have your notes, you can check the printout if you have. What is the formula and how can we apply it? You are 30 students, you know, and 30 students sitting here and no one can respond fast.
Yes, Doctor, it's RL1
over the sum of RL1 and I think RL2.
So again, it should be RL1 in the numerator. It should be RL1.
Yes.
Very good. Very good. Check. Check first the formula. Then tell me.
Oh no, sorry, doctor. It's up RL2.
Check it, then tell.
Doctor, we can't hear you.
Yeah, I know you cannot hear me. When I was talking, still you were not hearing me, I think, because no one was responding at that time. That's why I mute myself. Yes. Have you checked the formula now?
RA
Now
Over-
it's become RA. You changed to RA. RA
over RA plus RL1.
RL1. Okay, so quickly now put the value. What is the RA? RA you can check. It is 12.03 over the sum. So 12.03 plus RL1, and RL1 you know already 100. Calculate this one. Oh, sorry. Multiply by the total current, IT. Same IT. And how much is the IT? 1.05 milliampere. Calculate this now.
Uh, 0.11.
0.11 milliampere. Okay, recheck. Other students also. Is this same?
Yeah, same.
Same. So this way you calculate one load current, right? Now, what we need, as I told you, so we know that this current divided here in two parts. One is here, another is here. So guys, how can I calculate I2? This I2. I know IRL1 now. I know the total current. Can I calculate I2 easily?
Yes.
Which formula I should apply in order to calculate?
Same formula, but I R1 above.
So you want to apply current divider rule again? Yeah. Okay, we have another easy way. We can do it, what you said, but we have another way also. Anyone?
IR4 minus I total.
Okay, which formula, which rule is this? What you are saying?
Blader, sir. I Blader.
Yeah, this is called KCL, Kirchhoff current law. We can apply Kirchhoff's current law. At this point, we know that IT is incoming and two currents are going, which is I2 plus IRL1. This is something. And here we can calculate I2 just subtracting from the total current, which is 1.05 minus the IRL1, which is 0.11. And then I can get I2. How much is I2 now?
0.94.
0.94 milliampere. Now you know the I2. So come to this picture. Look this picture now. So this is I2. You look here. And this I2 is again dividing into two parts. One is I3, another is IRL2. So again, we can apply current divider rule. So total I2, we know that I2, then it is dividing into two parts. One current is here, another current is there. So we can again apply this one. Are you getting my point?
Yes.
So we can calculate IRL2 is equal to R3 over R3 plus RL2 multiplied by I2. This is the current which is dividing, and then you can get this one. After getting this, you can apply KCL, and then you can calculate I3. And the I3 is basically the bleeder current. So I3 will be I2 total current minus IRL2. Then you can get this current also. This is the way. Okay, so I am stopping this concept, the approach you should apply. Just put in the formula IRL1 minus IRL2, and IT you already know the total current. Then you will be getting the I bleeder. I bleeder yani I3, which is same, which is the remaining current. This is that one. Clear now?
Yes, clear.
So this you can take a screenshot if you want. As I said, I will not provide any recording. So you can take a screenshot. Questions will always change, will not remain same, with the time. The concept will be there always. Let's see this question. What's there? Find VCE and VAG for the given circuit. So how can we calculate? What is the meaning of VCE? Who can tell? VCE.
The voltage between point C and E.
Exactly. Point C and E. Yani from here we will go there. From here we can go there. Then from here to here. This is the path. So this is the voltage between C and E. Okay. So how can we calculate? What next? Similarly, VAG, A to G. This is A. So from A, you need to go to G. So this is the either we can go this way, and this way. And now for this one, how can we calculate? CBHE. So can I split this voltage? Can I write something like that? What that? VCE. I'm just splitting. So what is the path to reach from C to E? Can I write VCB then plus VBH
H
plus VHE. This is the path. So which voltage you know? What is just what I wrote here? Which voltage is given to you?
BH.
Okay, so how can we calculate VCB? VHE, BH is given only. These two are not. So how can we calculate this VCB? VCB yani voltage of this branch from C to B, and from C to B we have only one resistor. So if this is the R value, which we know that if we multiply by the current which is flowing here, we can calculate the voltage here. Similarly, for this one, HE, if I know how much current is flowing in this circuit, we can calculate the voltage here. Are you getting?
No, doctor.
What is this 5 given to you? What is this 5?
Resistance. R.
So what you need? You need resistance or you need a voltage drop? VCB is what?
Voltage.
Voltage. So how can you apply, calculate the voltage across this resistance? Which formula you need?
V equal IR.
So you should say Ohm's law.
Yes.
Why people are struggling with that one? No, easy. So V is equal to IR. So R you know, I you don't. So you need to calculate the I. Understand?
Yes.
So calculate the I first. This is the point. So in order to calculate the I, you need to consider now the how much current is flowing here. As I said, this is a source. So current will come from this source. It will go this way. And guys, same current will come here and this will back here. So it is a series circuit.
V over R, doctor. I equal V over R. So 20 over 6.
Yeah, this is a series circuit. And don't tell me 20 over 6. Understand? Around 15 minutes to explain this concept. Never say 20 over 6. 20 is the total and 6 is this individual resistor. Understand? So
Okay.
this is a series circuit, series here. Similarly, this is a source. Current will generate from negative to positive. This will go this way. This will come down and this will go again here. So this is the loop. Anti-clockwise current will flow. We can assume direction opposite also. But if we are assuming this way, what will be the signs we need to now consider? So you know that this is a negative sign here, battery terminal. This one is negative. This is positive. You know that.
Yes.
And what will be the sign of the resistance when the current enter from left side? What will be the sign of this terminal?
Positive.
Yes, it will be positive and this will be negative. Okay. And here same positive, negative. Entering point positive, leaving point negative. Getting?
Yes.
Similarly here, negative, positive, positive, negative, positive, negative, positive, negative. Okay, so this is the directions. According to the assumed direction of the current, these are the terminals, signs. Now, you need to apply KCL to this one, Kirchhoff law here. So how can we calculate the current? For example, if I say the current is IX and here is current IY. So I want to calculate IX. You can apply here KCL, KVL, Kirchhoff's voltage law. So total resistance, all resistance are in series or not? That's why current is same.
Yes, sir.
So how much it will be? VS over R total. 20 over, how much is the total? 6 plus 5 plus 9, 20. 1 ampere. Similarly, calculate the IY. How can we calculate the IY? VS over RT. VS there is 40 over 20. Then you can calculate 2 ampere. Understand? So now IY is here and IX is here. So you can just calculate, you can put these things in this formula. VCB. What is VCB? So here you apply Ohm's law. So do you know the resistance between C to B? 5 multiplied by the current. And before that, you need to check when you go from C to B, what is the first sign? Is this negative?
Yeah, negative.
So write negative and write multiply by the current. So this is VCB. Now you reach to B, then you are going to H. What is the first sign here?
Positive.
Positive 10. Then when you reach to H, you are going to E. What is the first sign now?
Negative.
Negative. So apply Ohm's law. By multiply by the current. How much is the current in the second loop?
2.
2. Exactly. Now calculate. Minus 5 plus 10 minus 10. 10 will cancel because negative positive. Answer is 5 volts. This is VCE. Understand now? See the answer. VCE is minus 5 and VAG is 30 will come. Now, second you will calculate yourself, and now we will take a break. So you need to calculate now VAG, guys. VAG. Okay. Can you just tell me the quickly how can we split VAG, this path? VA2. You need to AB. Okay.
B.
Yeah. Then V.
VBH.
Okay.
H.
VHG. Okay. Bus. So now calculate that one also. Okay. Now we can take a break. After break, we'll continue. You can solve it and take a break of 10 minutes. Inshallah, after 10 minutes, we'll continue. It's 2:03. We'll start 2:13. And in between, you can solve it also. Okay, guys. So have you done this?
Yes.
What is the answer for the VAG?
Voltage.
Hmm?
6 voltage.
Doctor,
Yes.
I've calculated all the voltages, but I don't know which one is minus and which one is positive.
I explained this one, dear. You just need to follow the what is the first sign during the path. I just calculated the same way here. So follow the same.
Yes, so going to be positive, right?
Which one? Which one?
The first one, VAB.
So, yeah, when you go AB. So what is the first sign? Can't you see this? Okay. Similarly,
Yes,
then B2H. What is the first sign?
Plus.
So you can see this is the plus sign,
positive.
positive. And H2E.
Positive.
Okay. Is it positive? Is this positive when you go from H to E?
No, it's not positive.
Then so consider accordingly, then you will get the answer. So your VAB is how much? Positive
6 times
1
plus 10
plus plus
plus
minus
7.
This is minus 5 minus. Okay, sorry.
No, it's a
HG.
plus.
This is
That's plus.
yeah. This is HG. This is HG. This is
7
HG.
times 2.
Yeah. So this is HG. I have to write. I explain here. We are not going there. We need to go this way, right? So this is positive. This is positive because the current direction is okay. Just a minute. How we are considering the current direction? Accordingly, we consider this. The signs. I told you. Look, Faisal, because of the current is moving this way and counterclockwise. So how it is entering? Positive. Where it is leaving? This is negative. Okay. So now the signs are clear, right? So what we'll do? Positive
Plus
7
times 2.
Yes. So 6 plus 10 plus 14. How much?
30.
30 volts. Bas, this is the way. Okay. So these type of questions may come where we can ask from one point to another point, how much is that? It's so simple. When you assume the current direction, once you assume the current directions, like we assume here this way and here this way, so accordingly the signs will be there on the resistances terminal, and then after that you can just follow the path and then choose the first sign accordingly. This is the way. Any other question, doubt here?
Clear.
Okay. Second thing is Wheatstone bridge. What is this Wheatstone bridge? The Wheatstone bridge consists of a DC voltage source, which is here, and 4 resistive arms. So 4 resistive arms are also there, like which is forming R1, R2, R3, R4. These are the 4 arms. So this circuit is called as Wheatstone bridge. It consists of 1 source, voltage DC source, and 4 resistors wire. The output is taken between the dividers. So here we took the outputs between these two. Okay, and we can connect any source here between that, and we can check it here. Okay. So frequently one of the bridge resistor is adjustable. You can see this resistance. There is an arrow. It is variable resistance. So we can vary this one. By varying this one, the output voltage will also vary. So this one resistance is variable. 3 are basically fixed resistance. So now when the bridge is balanced, so we called bridge is balanced or bridge is unbalanced. So when the bridge is balanced, the output voltage which we are getting here is basically 0. You will be getting here 0 output when the bridge is in balanced condition. Okay. Now the question comes, how do we know the bridge is balanced or not balanced? If it is mentioned in the question, it is balanced. So what is the condition? In which condition we will say that the bridge is balanced? So in the balanced condition, the product of the resistances is the opposite. In the opposite diagonal, arms are equal. The products of the resistances in the opposite diagonal, yani R1 multiplied by R4 equal to R2 multiplied by R3. So this is the balanced condition. If this is satisfying, we will say that the bridge is in balanced condition. If this condition is not satisfying, yani bridge is not in a balanced condition, it is unbalanced, and there will be some output here. Okay, this is like that. So see the question now. What is the value of R2 if the bridge is balanced? So it is given to you that the bridge is balanced. So the rule which we just checked, it is applicable now because of they said it is in balanced condition. So what is the rule? Do you remember? I said it is the product of opposite diagonal is equal to the product of another diagonal. Yani means R1,
R1,
R4 equal to R2, R3. Okay. And now what is unknown? R2. So for the R2, we can rewrite the equation. R2 is equal to R1, R4 over R3. Okay. So put the values now. 470, 270 over R3, 330. Calculate it and get the value of R2. How much it is?
384.
384.
0.54.
54 ohms. So this is the condition of the, this is the, during the balance condition, this should be the value of R2. This is the way. Okay. This way we can calculate. So this is one kind of question which is clearing the concept of Wheatstone bridge. See one more question now. So Wheatstone bridge, assume R2 is adjusted until the Wheatstone bridge is balanced. So we are assuming that we are adjusting this one and it is in balance now. So at this point, yani when it is balanced, the voltage across R4. So the voltage across R4, not the resistance, the voltage across R4 is measured and found to be 5 volts. So it is given at that time 5 volts. What is the voltage across R1? Now they are asking what is the voltage across R1. So R4 is given, they are asking voltage across R1. So how can we calculate the voltage across R1? So what is the given things to you? You have given bridge is balance. Bridge is balance condition. This is given. You have given V4, which is 5 volt. Okay. So how can we calculate this one? This voltage across R1. What do you think? Nothing else you have given, only condition and V4 is given. You need to calculate V1.
Doctor, is it the same?
No, why? There has to be a reason. Why it is same?
Yeah, I'm thinking they are the same because R1 and R4 equals to R2 and 3, but I can't explain it. I don't know.
No, so if you cannot explain it,
I'm
means
just-
it is wrong.
I'm just guessing, Doctor. I don't know.
No need to guess. Mathematics, you cannot guess. There has to be a logic, there has to be a formula, you know. During for the calculation, this is not the probability where you can say, okay, but it could be like that, could be like that. If there is some point you are thinking, there has to be a logic behind it. There has to be a formula. It is mathematics. So here guess not work. Here logic works.
Okay, I'll try.
Yeah, think about how can you calculate it. Basics, very basic rules. What you learn, you have to think about it. KVL,
Voltage
KCL,
divider.
voltage divider, current divider, whatever, you think about it.
V1 equal R1 over R1 plus R3.
Why? What is this logic?
Voltage divider.
How can you apply voltage divider? Which voltage is dividing? Voltage divider rule is applicable for the series circuit. So where is the series circuit here?
Okay.
Which is forming the series circuit?
Doctor,
Hmm?
in resistance, when we want to find the resistance, we apply the rule for V over I.
Where is the I? Where is the V?
For R4, the I need to be calculated, but I don't know.
So how can you calculate the V, I? Do you know the resistance value?
No.
Then if you know two things, then only you can calculate the third. Because one unknown is possible, but how you can? Do you know what is voltage? KVL, Kirchhoff's voltage law.
Yes, Doctor.
Yes.
What is this law? What it is state basically?
Dividing the
sum.
voltage.
Yeah.
The sum of the voltages and that's it.
The sum of the voltage.
Or
Equal voltage source.
Current, Doctor.
Voltage
least-
source equal the sum of the voltages.
The voltage source is equal to sum of the voltage drops. Okay. Or we can also say the algebraic sum of all the voltage along a closed path is equal to 0. So I told you that you can apply KVL to any closed path. Do you remember? Problem, when you come for the lecture, you should revise the previous lectures. Here is the thing which is mentioned, what I just said, Kirchhoff's voltage law. And I may explain here, you can apply Kirchhoff's voltage law to any closed path, provided you are choosing a closed path, either here or here, anywhere. And what it says, the path shown will have a sum of voltage is equal to 0. We know that one. So same thing you can apply there. And I'm telling you, this is the most difficult chapter. And if you will not practice, every question have different concept. But everything is coming from the basics. So if your basics are not strong or not you are not revising, then you will always struggle. So we can choose any closed path. For example, we can start from this point, we can go this way, and we will choose the path which is we have less unknown. When we say balance, what is the balance condition? When the bridge is balanced, what is the output at that time? If the bridge is balanced, what is the output at that time? Balance condition output. When the bridge is balanced, the output voltage is 0. And where is the output voltage? The across this resistance. So here we have 0 volts. Here we have 5 volts. This is something which is unknown across this resistance. So we can start from here. We can choose this path. We can go this way. We can come this way. And then we can complete the closed path. And while we are traveling this way, we can calculate the voltages. So as we are traveling this way, this is V1. This is VL, which is equal to 0. I am writing here. This is V4. So when you are going from here to here, which voltage is coming here? Again, as I said, traveling path is marked like that always. So you can apply here. What is this? V1. Then what is the sign here first when you reach here?
Plus.
VL
positive.
plus. How much it is?
5.
V4 is equal to Vs. What is V1 now? V1 will be Vs minus VL minus V4. Vs is 12 minus VL 0 because it is balance condition. It is mentioned balance. If balance, VL will always be 0. Minus V4, 5 is given. So V1 is 7 volts. This is the answer. And it is nothing. It's very simple. That's why I'm telling you this course will become very complicated if you not revise the concepts and if you will not revise the topics which you learn in the previous lectures before attending the next lecture. So this is the way
Doctor.
how can we calculate this one. Yes, sir.
Is there questions in the book to revise?
There are a lot of questions. You open the book, there are hundreds of questions at the end of the chapter. Examples are many. Examples are many. So you know the book, you need to open the book. Okay, and then you will see. Check this question again. Next question. So what is given to you now?
R1
Unbalanced.
and R.
Unbalanced. So when it is unbalanced, so output voltage will be 0 or not?
No, no.
No. So you can see voltage is given. Getting?
Yes.
Then what they are asking?
R4.
R4. So again, same way, because R4 is there, so we can choose a path, and I told you can choose any path, no problem. So we can choose this way, but we will choose the one which we know, because we know that R1. That's why we are not choosing this path. We are choosing this one because of we know R1, any voltage across R1. Then we will be going this way because we know the voltage across total. Then we will be completing the loop. So same concept. Now you can apply. So 12 voltage, 12 volts which you are having will be is equal to V1 plus VL plus V4. We need V4. Okay, you can write VS here. So VS minus V1 minus VL. 12 minus 1 minus 7. How much it is? Clear? 4 volts.
Yes.
Okay. So this is the way, and this is very basic. This is very basic. It's just KVL, Kirchhoff's voltage law, and it is about the series circuits. Okay. Clear? Any doubt here?
Clear.
Okay. So next, most important topic of this chapter now starting. Theorems or DC theorems. Here now onward we will be learning the theorems, which is basically going to help us to simplify a complicated circuit. So in this continuation we will be learning first the Thevenin's theorem. So Thevenin's theorem statement is important. We can ask you write the statement. So you need to write the statement also. So writing is also possible. So it states that similarly we can ask you what is KVL, write the statement, what is KCL, what is current divider rule, something. So you should know everything. Thevenin theorem states that any two-terminal resistive circuit can be replaced with a simple equivalent circuit when viewed from the two output terminals. The equivalent circuit is something like that. So you have any complicated circuit, for example, okay, you want to simplify that one. So in order to simplify that one, you need to choose two terminals, okay, any two terminals which you can mark like A and B terminal, okay. Then you will simplify whatever is given to you the left side, and when it simplify you will be getting one voltage and one resistance only. You may have multiple resistances, you may have multiple voltage source, current source, everything will gonna be replaced by VTH and RTH. So whatever you have complex circuit can be replaced by it. So how can we do this one? So for that there are steps which you need to follow, then only you can get the VTH and RTH. What is VTH? VTH stands for Thevenin voltage and RTH stands for Thevenin resistance. So the definition of VTH and the definition of RTH. What is VTH? VTH is defined as the open circuit voltage between the two output terminals of the circuit. Yani whatever circuit you have given, and you need to identify, you will be given, okay, we need to find the Thevenin circuit between point A and B. So you need to calculate the voltage between that point. That voltage is called VTH. Understand? Next thing, RTH. So RTH is defined as the total resistance appearing between the two output terminals. So two output terminals which is given to you AB, you need to calculate the resistance between them. Why you are calculating the resistance? You will remove the sources with their internal resistances. If you have voltage source, it will be a short circuit. Yani you will remove and connect a single wire. If you have current source, it is gonna be open circuit. It's like that. Then you will be getting VTH and RTH. Then you can draw that circuit in place of the complicated circuit. This is the way. So what are the steps to do this one? The first step, whatever question is given to you, you will remove. Maybe sometime you have given you have given a resistance connected between the point A and B. So you need to remove that resistance first. So open the two terminal between which you want to find the Thevenin circuit. So you need to open it. How can we open it? If resistance is there, we will remove that resistance. Once you remove, it will be open circuit. So first step. Second step, once you open the circuit, remove the resistance, determine the voltage across the terminal. Now you will calculate the voltage between points A and B. Okay, with that is called VTH, Thevenin voltage. Next step, determine the resistance viewed from the terminals. Means we will be calculating now RTH. So voltage source replaced with the short and the current sources replaced with the open circuit. This should be the step. Fourth step, connect VTH, RTH in series to produce the Thevenin equivalent circuit. So finally, you can draw that circuit which is VTH in series with the RTH. So these are the Thevenin circuit steps to solve any given circuit. So did you get some idea? I'm not saying 100%, but did you get the idea how to approach 1, 2, 3, 4 steps?
Yes, but we need example.
Exactly. With the example, things will be clear. But you just, for now, just look step 1, remove the resistance. Step 2, calculate the voltage. Step 3, calculate the resistance by replacing the short circuit with the voltage source, and for the current source, open circuit. And fourth step, draw this one. So this is something you should memorize. Now with the example, as you said. So here is an example. For example, I give you this circuit, and the question is that, guys, simplify the given circuit across the terminal A and B. This is terminal A, this is terminal B. You need to simplify. Yani, whatever is here to the left of A and B, it is going to be simplified. You need to simplify this one. So according to the first step, what is the first step? Do you remember?
Open the circuit or remove the resistance.
Removing the circuit, okay, through which you wish to calculate the current or the voltage. Yani we can also calculate the voltage and current in this resistance by applying Thevenin theorem. Okay, for example, this is IR. Question is given, calculate the IR by applying Thevenin theorem. So we need to find first Thevenin circuit. So what do? We remove this resistance first. This is the first step. So you will be having this circuit. Okay. And then what is the second step? Second step is to calculate the voltage between these terminals. Okay. And if you look closely here, this is A, this is B. So can I say VTH is equal to VAB? It is same, because AB yani voltage between point A and B. So we are writing A and B, and VTH is what? Yani this voltage. So guys, I want to measure this voltage from this point. So how can I calculate that one? Can you tell me again? We have discussed similar question, how to reach A to B. If you remember, we discussed about that calculation of voltage between 2 points. You calculate VAC, VAG. So we need VAB. How it is possible now?
VAB equal VS.
VS or
V,
some point.
V.
Do you want some? Should I give some label here like this one? Now, easy to have these labels. What do you think now? It is simple, like you can apply here this way. You can follow this path. VAX plus VXY plus VYB. So we reach from A to B. Clear?
Clear.
Okay. So now we need to calculate the voltage across R2. So can you tell me how much will be the voltage across R2? How can we calculate the voltage across R2? So we have a source here, voltage source, which will generate a current. Current will go this way, for example. Then after reaching to point X, where the current will go?
We'll divide, Doctor.
Divide.
Yes.
So
Y to and A.
So do you think current will go here and it will
Yes.
fly in the air because current have wings? Current
No.
can fly?
No.
Then you know the basic. What is the basic rule to flow the current? What is the rule to flow the current in any circuit?
A closed circuit has to.
Closed path. So it cannot go there. So all current will pass here and go here and go here like that. So no current will go here. Reason? Because here is open. Getting the idea?
Yes.
So no current is flowing here. Yani no current. I is equal to 0. So if current is 0, so how much will be the voltage? Ohm's law. V is equal to I into R.
0.
0. So can I say VAX is 0? VAX.
Yes.
Okay. Next thing comes. So yani total current going here, 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 flowing here. Okay. Understand? So we need to calculate the voltage X and Y. X and Y. And this is basically the voltage across R3. And if you look this circuit, is this a simple series circuit with a 2 resistance or not?
Yes.
So can we apply voltage divider to calculate the V3? Because V3 is the voltage which is we are saying VXY.
Yes.
So what is the voltage divider rule formula to calculate the V3? It is R3 over R2 plus R3 multiply by V1 if it is V1. Clear? Understand this point?
Yes.
Yes.
Now,
Doctor,
yes,
it's R4, not R2.
this is R3 or what?
No,
Okay,
why?
here. Okay. R4, I change it here, R4. Now here V by B. What do you think about V by B? V by B. Again, you need to calculate this voltage. And if you look from here to here, how much is the resistance?
0.
0.
Hmm.
So if resistance 0, how much will be the voltage?
0.
0. So what we got it from here? We got it from here. VTH is basically VAB, or what is that one? VAX. Yani it is V3. Are you getting?
Yes.
Which is basically R3 over R4 plus R3 multiplied by V1. This is the way. So this way we can calculate the Thevenin voltage. This is called the VTH. Okay. So this is the second step. You can see now here, second step. I wrote it there for you so that you can understand what I want to explain to you. This is VTH. So agree with this formula now? Simple for this particular circuit.
Yes.
Okay. Yeah. So this way we can calculate Thevenin voltage. Third step. What is the third step, guys? Do you remember? Short circuit the voltage source. Remove the voltage source and replace with a wire there. Just connect a wire from here to here. Make it short. This is the meaning of. Okay. So what do we do now in third step? This is the third step. So we remove here voltage source. We remove the voltage source and just connect a wire here. Okay. So this is the circuit what we are having now. So we need to calculate the resistance between A and B. Okay, so I muted all. You can unmute yourself. So look now, R3, R4 and R2. So guys, you need to calculate basically the resistance here between A and B. If you look from here, how much is the resistance? So you need to identify the relations now, and then you need to simplify. Can you check? This R4 and R3 is in parallel now because they are connected with one end common and another end common. Am I right?
Yes.
So this way you can calculate, you can replace two resistance with a single resistance. If we can draw the simplified, this is a simplified. And this is what we can say 3, 4. This is R2. And how we calculate the 3, 4? Product over sum rule. Remember?
Yes.
Yes.
And now if you look, they are in series or not? Between AB. So
Yes.
we can, total will be, RTH will be this. R3, R4 plus upon R3, R4 plus R2. So this way we calculate the RTH. So this is the total resistance between point A and B, like that. So this way we calculated VTH, we calculated RTH. Fourth step. Fourth step is now we can draw the circuit, Thevenin circuit. This is our Thevenin circuit. Okay, now we can connect back the load resistance here. We can connect the load resistance back, which we remove in the beginning. This is the load. Okay, now if we have asked calculate the current in this load, resistance I. So can you just identify which type of circuit is this? Which type of circuit is this?
Series.
Yes, it is a series circuit. So this is the current I. So if I ask you guys calculate the I, you will be calculating VTH, yani the voltage divided by the total resistance. So which is that RTH plus R, and you can get the current. Clear?
Yes.
Or if I ask you calculate the voltage here, which is VR, how can you calculate? After calculating the current, you can multiply with the resistance, or we can also apply voltage divider. VR will be R over R plus RTH multiplied by total voltage, which is VTH. Then you can get this one. Is it clear?
Yes.
Okay, so this is mentioned here, these two also. So after that, you can do this one. So now quickly, I will take 2, 4, 5 minutes also, because we have discussed this concept. So it's good to have one question from this concept. Now guys, this is the question for you. And here we need to find VTH first. So first is calculate the Thevenin voltage for the circuit. So this type of question will come to you. So they ask you what is the Thevenin voltage of the circuit. So guys, do you remember the steps? What is the first step?
Remove RL.
Remove RL. Yes, exactly. So we need to remove it, right? So first step,
Yes.
what we are going to do, we need to remove. So step 1, remove it. So once you remove, what is your circuit? We have to redraw. Be careful, you have to redraw again and again, multiple times. So don't be lazy. Do it again and again and mark A and B. Okay, this is R1, this is R2, this is VS. Now guys, so first step, what is the second step?
Calculate voltage.
Calculate voltage VTH. Okay, which is basically VAB
R2.
or R2, VR2. Okay, how much it will be? Can you tell me? Can we calculate easily?
R2 over R1 plus R2.
Any
multiplied by-
voltage divider we can apply, say like this. Okay.
Yeah.
So we can calculate by voltage divider R2 over R1 plus R2 multiply by VS. So put the values. R2 is 27 over the sum, which is 37 multiply by 12. Calculate it and tell me the answer. How much is VTH?
9.75.
9.75 volts. Okay, check it again. Any other students?
8.75.
8.75. Okay, so 27 over 37 multiplied by 12, 8.75. Okay, check with one more student, because one said 8.75, another saying 9.75.
No, it's 8.
8.76.
8.75, whatever. Okay, VTH. Now guys, what is the third step? Third step is for RTH. So what do we do in the RTH? What do we need to do in the third step?
Replace VS
With short circuit.
RTH.
No, replace this source with the short circuit. It's not with the RTH. For the RTH, yani you will remove the source like that, and then you will connect it with the wire, short circuit.
Yes.
Okay, this is basically, now you can calculate the RTH. This is A and B point. So this is R1 and R2. Now, can you tell me what should be the RTH now? R1 and R2, only two resistance we have. How they are connected? R1 and R2. You need to focus A and B points and how they are connected.
Parallel.
Parallel, yes, they are connected parallel. So R1, R2 over R1 plus
R1
R2.
plus R2.
Okay, so calculate quickly. 10 multiplied by 27 over 37. Check it, how much you are getting.
7.29.
7.29 ohm. Kilo ohm. Yeah. 7.29 kilo ohm. Now RTH is there, VTH is there. Step 4. We can draw the Thevenin circuit. So this is the Thevenin circuit. So your circuit, this is terminal A and B. This is VTH. This is RTH. And now guys, you can reconnect the load which you remove in the beginning, which is RL. This is called your Thevenin circuit. Clear?
Yes, clear.
For example, if I ask you in the beginning, guys, calculate the IL by applying Thevenin theorem. Calculate IL by applying Thevenin theorem. So you will have to follow step 1, step 2, step 3, step 4. So you reach here. Now you need to calculate this IL. So how can we calculate this IL, guys? It's very simple. If you look this circuit, the Thevenin circuit which you got after step 4 is a simple series circuit. So I can calculate IL is equal to VTH, total voltage, upon total resistance. Am I right?
Yes.
So how much is VTH? 8.75 over total resistance, and RTH plus RL. So RTH you calculated 7.29, and this is 68 point this. And by the way, this is in kilo. So be careful. Now calculate IL. How much is the IL? Denominator is in kilo ohm. So what should be our current? .75 divided by 75.29.
0.11.
0.116.
6, yes.
Yes. So how can you remove 6? 6 is very important. And so because it's 0 point, so if it's something coming 0 point something, at least keep it some value. It is IL. Understand? If I ask you VL, how can you calculate VL? What is VL? When I say VL, what is the meaning of VL?